Hey everybody, and welcome back to another fun and exciting pre-calculus class. In today's lesson, we'll be in chapter number 16, the last chapter. Congratulations. All right, this is a momentous occasion for you, and I applaud your effort this year. Pre-calculus is not an easy task for anyone, so good job pushing through, getting to the end. Chapter number 16 is on page number 308 in your book. 308. Let's go ahead and look down at it, and let's talk about the limits of calculus. What are limits? Well, let's first of all just kind of really set up the stage, right, for what is calculus. In its most basic form, the easiest way to understand what calculus really is to say that it's about the slope of a line tangent to a curve and about the area under the curve. You might be thinking, what in the world does that even mean? Like, I've taken pre-calculus and I still don't even know what calculus is. Well, let's say that we have a curve, okay, and this is like a sine wave or something like that. Well, the area under the curve should be fairly easy to figure out. It's like saying, okay, so from this point to this point, I want to know how much area is under this curve, let's just say. What we're learning right now, these limits, this right here would be a limit. And there's different things that can limit us. Like we can just say our own limits. We can say, I want the limit to be 2, or I want the limit to be 7. But there's also other things that limit what we're doing in calculus, such as things called asymptotes, and I think we've covered that in Algebra 2 just a little bit, and then maybe a little bit here in pre-calculus. But basically it's a line that your graph or that your curve can approach, but it can't cross that line. It can't cross over here. It's got to go up, and it can get closer and closer to that line, but it can never actually touch the line. So these types of things, like when the denominator goes to 0 or something like that, these cause asymptotes in your graph, and your line can't approach it. These cause limits. Your graph is limited because it can't cross 0, for example. It can't cross 10, whatever it is. So this is pretty much the basic idea of calculus. Now, there's one more thing that it says, and it talks about tangent lines. So let me change the color here and let me kind of draw a tangent line. Now I'm just going to draw a line right here. That's not a tangent. But what tangency means is that your line only touches your other line in one point. So for that to be a tangent line, I would have to come like right here. So it only touches it in one point, right? There's only one point touching that line. Now, one thing that you can do with a tangent line, that's not a tangent line because it goes right through the thing, right? So there's a point of tangency that is horizontal. And that point of tangency that's horizontal is when it's called the trough, or basically the bottom, the lowest point. The minimum point is another word that we use for this curve. Well, at this minimum point, we have a line of tangency that's horizontal. But we can also have points of tangency that fit basically every other slope that we have. We had to find where it fits. And so here's what calculus is. Calculus is basically taking these lines of tangency where they touch once, and it's actually using limits to limit ourselves, and it's using some other things that we're going to be learning in this chapter, like derivatives and integrals, to be able to take that line, move it around, and to be able to figure what is this curve doing and what is the area doing under the curve. That's really what calculus is all about. Okay, so jump back over here in your book, and let's go ahead and talk about some other things here. Let's talk about the limiting process. I kind of mentioned that. I referenced it as I was talking about what calculus is. But the limiting process is this idea of you can't go any further. It's like a brick wall, okay? It's like your numbers come up to the wall and then they stop at the wall. And usually what happens when they get to the wall is they go up or they go down, for example, if you're graphing it. So they'll come up to 0 and they'll almost touch 0, but then they'll go up, okay? And so that's where you get curves and different things happening on your graph. like we've done parabolas and we've done hyperbolas and circles and all these different things. When you have these curves, it's coming up to a line, and it's like, no, I can't touch that line, and I have to curve back. There's reasons, there's mathematical reasons why that happens, but this process or this idea of limiting something is very important to what we're going to be learning in calculus. Something else here that's just, to me, just mind-blowing. This is pretty cool. So England's Sir Isaac Newton lived in 1642 to 1727. And this other guy, Germany's Gottfried Leibniz, lived in 1646 to 1716. If you compare these dates, they're really close together. Born within 4 years of each other, died within 10 years of each other. So pretty neat. Their lives were basically just like on top of each other, but they lived in two different places. Now, another thing that's kind of cool is, as far as we know, these two guys, before they discovered these concepts of calculus, didn't really know each other. They didn't ever collaborate and tell each other what they were doing. So both of them had their own ideas about calculus. And one thing that kind of makes calculus a little interesting is some books will use the Sir Isaac Newton form of teaching calculus, and some will use the Leibniz form. So sometimes you're going to see different formats of doing certain things. Here's the cool thing. It's doing the same thing, but it's kind of using a different notation or a different kind of method, if you will, to get the same things accomplished. So it's kind of neat that these two guys were contemporaries with each other. They lived at the same time, and they were doing and developing the same thing, but as far as we know, they never talked to each other about it. So kind of cool. Other mathematicians have come in and have helped to develop it to where we have it now. All right, on the next page, page 309, we really get into and start talking about limits. What are limits in calculus, and kind of how do we deal with them? So if we consider the function of x equals x squared, to determine the value of this function, if we use the number 2, we can actually just substitute 2 into that, and it will tell us. So we know that if we plug into 2 squared is 4. So we know mathematically that this equals 4. In mathematics, in calculus especially, this is called limit notation, and we write it a certain way, and it's written like this: LIM with an x to the with an arrow to the 2, x squared equals 4. And the way that we read that notation is the limit of x squared as x approaches 2, and that's down here underneath it. So the limit of x squared as x approaches 2 is equal to 4. Now, here's something that's kind of crazy. Up until this point in your math careers, for the most part, if they gave you something to plug in, you could plug it in and it would give you an answer. What happens here when we get to calculus and limits is sometimes they'll give you something, and when you go to plug it in, it doesn't quite work out. It's like, what's going on? So let's jump back over here to my computer and let's take a look at this problem. So we have the limit as x approaches 2. And so typically what you can do is just take this 2 and just plug it in, and it will tell you what it's supposed to equal. But watch what happens here when we plug in 2. So 2 squared minus 4 over 2 minus 2. 2 squared is 4. 4 minus 4 is going to give you 0 over 2 minus 2 is 0. 0 over 0 isn't really an answer. It's undefined. We don't know what it is. Take 0 and divide it by 0. That doesn't make any sense. So in other words, when we look at this right here, we would say that this is undefined, okay, if we're using what's called the substitution method. However, with limits in calculus, we don't settle for that as an answer. We don't say, oh, okay, so it's undefined and we don't know what the limit is actually going to be. We try different things, and one of those things is we try to simplify this as much as possible before we substitute in. We try to cancel out, because what you're doing, what literally you're doing here, is you're canceling the thing that makes it go undefined. So you're trying to reduce it so that it will cancel something that now you can get an answer. So what do I mean by that? Well, let's take this and let's actually figure it out. So let's factor this top binomial right here, and we're going to get x plus 2, x minus 2 over x minus 2. Well, this x minus 2 is what's giving us the problem, okay? And again, this is a concept that we actually touched on in Algebra 2. You've done this before. So this shouldn't be like, what is he doing right now? We've done this, and when we did this right here, if you remember, we had to write that x cannot equal 2. That's the number, this number right here, the very limit that we're trying to find, is the number that makes this go undefined. So in other words, if we can take out that limit, if we can say, okay, let's remove that number, and now let's see what the limit really is. Let's take out the number that makes the whole thing go weird on us. So what we end up with this right here, x plus 2. So if we have x plus 2, now we're going to try to find the limit as x approaches 2 of x plus 2. You would do the same thing, and you would sub in your 2 now, and you would get 2 plus 2 equals 4. So our limit as x approaches 2 of, now this is the limit of this question way back here, right? So you don't say the limit of this is undefined. You say the limit of this equals 4, because you reduce it out, you find the limit, and then you do have something that makes it go to undefined. In other words, here's what's going to happen with this right here. When you go to graph it, that is going to come up to the 2, and then it's going to be an asymptote. You can't cross that 2. But the actual limit of the question is 4. That probably doesn't make any sense to you, and it doesn't really need to right now. It's just something that you need to learn how to do. Let's go back to the book real quick, and let me show you one more thing. When we do this, so here's an example. If we just had x, and we are going to build a chart to try to figure out the limit. What we would do is we'd start with 1. You can start with any number here. They start with 3. They start with 9. But what you're trying to do is you're trying to say, okay, as this thing approaches 2, let me check this out, as it gets closer and closer to 2. So you put in 1, 1.5, 1.7, 1.9, 1.99, 1.9999. And so in your function, what's happening is you're actually squaring the number. Look, when we square 1, we get 1. When we square this, we get 2.25. And we just keep on going and going and going. And what you're going to see is that this limit right here, x squared, is approaching what number? It's 1, 2, 3, 3.9, 3.9999. As we're going to 2 right here, this number is approaching 4. Okay. Same thing here. When we plug in on the other side of it, we go 3, 2.5. So we're going to 2. Again, 2 was our limit, right? And so as we're approaching 2 from the other side, so this way we're approaching it from the underside, if you will, from the 1 to 2 side. This way over here, we're approaching it from the upper side, from the 3 to 2. So we're coming backwards at it. 1, we're going, let me show you what I mean by that, because I'm not sure that I'm getting that across. So let's just draw a number line. So if our 2 is here, and our 1 is here, and our 3 is here. So what we're doing is we're approaching it from the 1 side, and we're approaching it from the 3 side. So it's like we're sandwiching that number, since we can't use 2, right? Because what happened when we try to use 2? When we tried to use 2, the thing went to undefined. So we're trying to come into it from both sides, because we can't use the number 2. So when you do that with your limit, you can build a chart. Now, this is a bad idea. You're not going to want to build a chart every time. They're just showing you how to build a chart to figure out your answer. Okay, they're showing you how to approach it from both sides. The better way to do it is to use this example down here. So you could try by substitution, but when it goes to indeterminate, the easiest way to do a limit is just substitute it, right? And a lot of times it'll work. You'll be able to find your limit. But sometimes whatever limit you're looking for is the very number that makes it go undefined. So if it makes it go undefined, then you have to change your method of finding it. You can't just do just a straight substitution. You have to do something else. You have to do some sort of simplification. In calculus class, you're going to learn all kinds of different simplifications that will allow you to find the limit. Here, they're just saying, hey, simplify it. You'll see what that means. You'll go more in depth into that in your actual calculus class. So on the next page, you're going to just find a bunch of work for you to start working on, a bunch of exercises, practice problems. And so, use those methods that we kind of learned right there. Right here, they're just wanting you to just do direct substitution. Down here, you might have to do a little bit more because you might get into this one and you might say, okay, the limit goes to 0. Oh, that makes my fraction go to 0. So I can't do that. When your denominator is 0, it goes undefined, so you've got to find another method. Here, when we sub in our 3, we get 3 minus 3. It's back to 0 again. So we have to come up with a different method. So, work through those different methods, work through that substitution, and just keep trying this. The limits aren't really that complicated. They're really not. So don't make them hard. It's just substitution. If you can't substitute it, do some simplification first and then substitute. Okay? That's all I've got for you in this lesson. Hopefully you learned something there. If you missed anything, slide it back and watch it again. We'll see you later. Have a good one. Bye-bye.